Hi, in this video, I'm going to talk about some suggestions on how to implement the subset sum solution. So here is the pseudocode of the solution to the subset sum problems, which is what you're going to implement for this week's assignment. Now, your exact code is going to differ from person to person. So I'm going to make suggestions on implementing two classes to make implementing this pseudocode easier, and your assignment might require you to implement one or both of the classes, well, or none of them. So please read your assignment for the exact requirements. So here is the first class that I suggest that you implement, and that is class subset. And we are going to use an instance of the class to represent what's in L in the pseudocode. So if we look at this pseudocode carefully, then what the subset should be able to keep track of is all the elements in a subset, right? And then as a function of all the elements, it should be able to yield the sum of all of its elements in that subset. Then it follows naturally that the class subset should be able to do the following few things. First, that it should implement a .add method that adds a single item or element to the subset itself, right? So if we have an instance of subset that has, say, two elements, 10 and 12, then when we add an element, say 8 to it, then the subset would contain three elements, 10, 2, and 8. And the second thing that subset class should be able to do is to return the sum of all the elements in itself, right? And you should implement that as a property, which is kind of have a better syntax for just retrieving the sum or the subset. So if it's a subset has the elements 10 and 2, its .sum property should return the value of 12, right? And just as a little hint here, that you can either choose to sum up all the elements in the subset every time that property sum is called, which is fine, but it's a bit slower because you have to do it every single time. Or if you do it properly, you can optimize this a little bit such that this sum property doesn't actually have to add all the elements every single time that it's called. So it's up to you how you choose to implement this property. The last thing that subset should be able to do, especially if you look back at the pseudocode, is that when we add a new element to the subset, a new subset is actually created, right? And that new subset with the new element is the one that is added to the collection. So that means what the subset must be able to support is the ability to replicate itself. Now it's up to you how exactly what you want to implement this, but the only requirement is that the copy, the way that it tracks of all the elements, is that it just keep references to those elements that are in the original subset. So, and that's, if you remember, that's like doing a shallow copy. Okay, so do not make separate copies of the elements themselves and put those in the copy. Okay, so like I said, it's up to you how you do it. You can either write a .copy method, just like set actually has a explicit .copy method that makes a shallow copy of itself. Or if you choose to support the copy module and use copy.copy to make shallow copies, you can do that as well. And for that, you just have to implement the dunder copy method for this class. And when you think about it, this class subset is really very much like the Python set built-in data type, but with probably a lot fewer functionality. So you really should just use Python set to implement the subset class. Now, exactly what the relationship is between subset and set, that's up to you. You can either have subset inherit from set, so that would be a is-a relationship, or you can, inside subset, instantiate a set. And that will be a has-a relationship, right? If you remember from your inheritance class. So how you want to do this, it's up to you. There are pros and cons to either of these approaches. So think carefully about how you want to do this. So the next class I'm going to suggest that you implement is a class collection that, if you look back at the pseudocode, is this collection of all the subsets that we have generated so far. So obviously, to represent a collection of subsets, we could use a list. Well, actually, we could use a set too, but when I try to use it, I ran into a couple problems that we haven't quite covered yet. So using a list to store all the instances of subsets is fine. And the collection class should be able to do at least two things. The first is to expand the collection itself by replicating all the existing subsets that are already in the collection, and very importantly, to add a new item to all of the copies. Right? So if you look at the pseudocode, that's basically what this line does. And then remember, there is an optimization that this expansion can do, and that is if the sum of all the new subsets is larger than the target that is given, then we don't really have to add those subsets back to the collection, right? So an example here is that if the existing subsets are the two, one is an empty subset, another is a subset with number 10, and we expand it by the element 2, and our target is 11, then after this method is done, this collection should have the two original subsets, right, empty and the one with the 10, and then we also now have a new subset of just a single element 2. Now we don't have the new subset of 10 and 2 because the sum of that exceeds our target of 11. Okay, so that's expand by. Another one is just a getter to get the maximum subset that is already in the collection itself. So that is kind of the answer at the end. That's what we want to get out of the collection. So once you define the two classes and tested them individually so that you are confident that they work, you're ready to define the subset sum function, which takes two parameters. S is the set of positive integers, and target is the target that we've been talking about. So for this function, you should just implement the pseudocode or the algorithm for the subset sum, and you obviously should use the two classes you define, mainly the collection class, which itself then use the subset class. So if done properly, this function should really just be a few lines of code. So this concludes my overview of the implementation of the subset sum algorithm.